Okay, so I just want to review real fast what we're doing graphically. We'll look more at this later, but just keep this in mind as we go along. There's a couple ways of graphing these and getting the answers. We're not doing this today, but just here's what it means. That if you want to solve absolute value of x minus 2 equals 5, you can graph these individually and just see where they intersect. Y equals 5 is just right here. Y, there's positive 5, 1, 2, 3, 4, 5. And where do they intersect? At negative 3 and positive 7. That's one way of getting the answers, negative 3 and positive 7. Over here, this is what we did before. We said right here we can say that this is a center of 2. And this means a distance. Absolute value is a distance. This means start at positive 2 and go 5 to the right. You can get an answer of 7. And go 5 to the left. You can get an answer of negative 3. And there's another way of getting an answer graphically. Okay? So two different graphical ways to get the same answer. Okay? That's where basically what we did on Tuesday. Right? No big deal. Next, little review. Where's the center once again of something like this? Yeah, remember it's going to be the opposite. So positive 3. If there is no number, 0. Negative 4. Negative 2. So the general rule was opposite sign. Opposite signs of some side. However, this is not going to work. One thing we did do on Tuesday, we gave you some nice numbers where there is no coefficient right here. There's no 2x, 5x, negative 10x. It's just x. So when we have just x, we know the center really easily found. It only works this. But once we get to here, the center is not going to be positive 6. The distance is not going to be 20. So that's what we were looking at and saying, well, what if it's not these nice pretty problems, but something that has a little more work. Of course, the distance for all these will be the same. 10, 7, 2, 1, 5. And again, today we're looking at this. It's not 20. And just to prove that, if we did do this, 6 and we went up 20, that'd be 26. So if you plug in 26 into here, 2 times 26 is 52. 52 minus 6 is going to be 46. And absolute value 46 is not 20. So I know that doesn't work. Like work really fast to figure out that it's just not the same stuff. Real fast, why was this no solution? Big idea. We know how to solve the problem, but if we don't understand what the problem is, we can't figure these kind of questions out. Because why can't you have negative thinking? Because it doesn't exist? Because it's impossible? Are good answers for that? Yep. You're right. You're right on the money. Yeah, even if you're driving, as I said on Tuesday, even if you're driving backwards in a car at 85 miles an hour running from the cops on the way to Vegas, you're still not doing negative distance. Right? It's still positive distance. So this is a distance. Absolute value is a distance. And distance cannot be negative, so that is no solution. Okay. Very good. All right. Ready? Okay. So let me give you an algebraic way. So we did the geometric way, graphing way. Let's do it algebraically. Just in case these numbers start turning into something not quite as nice. This is one of the nice ones I'm going to show that we already know how to do, but then I'm going to show you algebraically, and I'm going to show you how do you do the algebra based on the graph. So here we go. We already know this has a center of 2, yeah. And actually I shouldn't use a dot because it's not an answer. It just, that's the center, it's at 2. Now, this is the distance, so it means I go 10 to the right. There's an answer. That is a dot. And And that answer would be, yeah, 2 plus 10 is 12. No big deal. Over here, if I go 10 the other way, which would be negative 10, 2 minus 10 is negative 8. So I can get my two answers, just like you have on the homework you just did, just by using a graph. Now, let's do the same thing, but not using the graph. So we have two problems here. I did a 2 plus 10, got 12. I did a 2 minus 10, I got negative 8. So I'm going to do two equations. I'm going to do, well, when is the center, because this is the center, and what is positive 10 away from the center? So I'm doing the right-hand side right now. When is x minus 2 equal to positive 10? And I can solve this algebraically, just like we've always had, add 2 to both sides. I know it's simple and it's restating the obvious, but this is how you do it algebraically. Okay, so I can get my answer without using a graph. And if this changed to 2/7 and 10.54, it would still work just as easy. But whereas a graph, if these were fractions and decimals, it wouldn't work that well. That's where we're heading. What if we don't have nice numbers? And of course, let's do the other side. Well, when is the center? Again, the center is x minus 2. When is that equal this time to negative 10? We did a positive 10, and now we'll do the negative 10. And doing the same algebra, you'll get, well, add 2 to both sides. And just as we thought, okay, negative 10 plus 2 is negative 8. We get the same two answers without using a graph. So today you'll do all these just the same, but without using a graph. And of course, we can still do a check just to verify, okay, just like we did yesterday, does 12 minus 2 absolute value, does that equal 10? And negative 8 minus 2 absolute value, does that equal 10? And sure enough, both of them do. If you probably figured out by repetition that one of these comes out to the positive, one of them comes out to the negative, and you take the absolute value of both and you get positive. Some people like all the directions in words. Here's what we just did in words. We set up the two equations, one to the positive side, plus 10, one to the negative side, minus 10. Notice how we did not change the center. The center doesn't move. So they're both x minus 2. Some will say, well, I thought absolute value makes positive negatives into positives. Well, not where we're starting from, just the directions we're going. So left side will always stay the same. It starts at 2, starts at 2, 10 to the right, 10 to the left. There's your two numbers. We solved those two equations, got our two answers, and then we check those two to make sure they're right. Okay. After doing all that work, actually turn the car on, see if it starts. Did you fix it or not? All that work, if it didn't work, you go back and you refix it until it does work. Hey now. Alright. I'll do another one just a little bit faster, not as much explanation, and then I'll let you guys just try some on your own, make sure you got it. Okay. This time, I'm not going to do the graph to start off with. But I know I have a center. And I know there's something that's 5 to the right, and I know there's something that's 5 to the left. So I'm going to set up my two equations. The center is the same for both. It's just one is going to be 5 to the right, and one's going to be 5 to the left. So one's positive 5, one's negative 5 from the same exact center. So that's how you set it up algebraically, and then solve those two, doing this to both sides, doing that to both sides, to get your answer. From this point on, this is complete review from pre-algebra solving of two-step equations. The only thing new here is the idea of why is it 1 plus and 1 minus? Can you answer that question? How come one is positive 5, one is negative 5? You don't know the absolute value. Don't know the absolute value, and? Yeah, one's to the left, one's to the right. So as long as you know this isn't just a rule, well, we'll just do one positive, one negative because that seems like a good thing to do. You understand that we have one answer, we have two answers, they're the same distance apart, but one's to the left, one's to the right, so one's positive, one's negative. Okay, let's go ahead and solve. Now the nice thing here is the output's the same. They're both 2f minus 1, right? So we're going to do the same thing to both sides on both of these. Here we got a minus 1, so I'm going to add 1 to both sides. get my answer, simplify it. But it's going to be the same thing over here. I'm going to add 1 to both sides on this one. Now the arithmetic will be different because one has a positive 5, one has a negative 5. So I got 0, right? Negative 1 plus 1 is 0. Bring down the 2s. Bring down the equal sign. And if you want to do the whole left side and get an answer, and then the whole right side and get an answer, that's fine. I'm going to bounce it back and forth. 5 plus 1. Negative 5 plus 1. And 4. There's where it's different. Because one side is positive, one side is negative. Divide by 2. 1s. Divide by 2. That's good. So we got our 2 answers. Negative 2 and 3. There you have it. Notice how here's one answer. Here's another answer. If I graphed it, I just have 2 dots. Just make sure the smaller answer is on the left, the bigger answer is on the right, and you're fine. You don't have to put all the numbers in between or anything else. Okay? And of course, just go ahead and do the check. You don't have to do it here, but on your homework, please do it. Algebraic. It's all mathematical. One with graph, one with not. Alright, let's try, you guys try one on your own. You have this all written down? Try this one. So here we go. What are they? What are the two? And?
Equals positive 5.
2, yeah, equals positive 5. And these stand for the answer to the left and to the right. Notice how they told me these reversed, like I have positive 5 over here, negative 5 over here. It doesn't matter. Okay. Solve both of these, add 2 to both sides, divide by 3, you get an answer of negative 1. And over here you get an answer of 7 over 3. Right? Negative 1, right? Add 2 to both sides. Negative 5 plus 2 is negative 3. Negative 3 divided by 3 is negative 1. How do I graph those two? See, this makes it easy because the only thing you have to figure out usually is which one's bigger, which one's smaller. But of course, if you have a negative, that's small. So negative 1's here. And I'm putting these in random places. I'm not like making sure it's scaled. Where's 0? I don't care. Just make sure both are solid dots and on the number line. Yeah. No, we don't need the middle. We do not need the middle. Okay, so your solution set would look like this. And just in case we're not sure about the check with the fraction, here's how that would look. It'd be 3 times 7 divided by 3 minus 2 equals 5. This is what a check would look like. And I warned you on Tuesday that don't stop at this point and say, well, look, I'm done because I got the answer. Prove it's the right answer. Get the answer value. Okay, one more. Write that down if you don't have it or if you don't know it. Write that down. That's what you're doing right now. Have that check down. So you're not going to come tomorrow and say, Mr. Hodgson, this one had a fraction, so I don't know.
Wait.
Here it is. You know. Write it down. And then the worst thing you want to do is, in high school math, is say, I don't know because it has elementary school math. And third, learn in 5th grade, between recess and lunch. Okay, you don't want to be in high school saying, that's difficult. You might have a question here or there, just don't say it's hard and you can't do it. You can't. Okay, here we go. Try this one. The last one. So, as I mentioned before, the first step is not arithmetic, really. It's just algebra. We already know we have to have 1 equal to 1/4, positive, and 1's going to be equal to negative. So if you sat there and said, well, I don't know how to start it, you're kidding yourself. You're just saying that because you don't want to try. Try not to be that person. Okay? Next step, just like on all the others, is to add 3/4 to both sides. Okay? And I'm going to write it on the side here. That's how we normally add fractions. Same thing over here. 3/4 each side. Okay. Now, I mentioned earlier, you're not going to feel so good after I show you this if you're saying fractions are hard. Here we go. Fractions are hard. What is 3 plus 1? 4. Fractions are hard. I can't.
1 whole. 1 whole. Can you just put 1 whole?
Same thing over here. 3, well, negative 1 plus 3 or 3 minus 1 equals 2. Fractions are hard. I had to do 1 plus 3 and 3 minus 1. Boy, that was hard. This is why I'm telling you, you guys, if you're still saying fractions are hard, yeah, maybe this is a little confusing because there's other stuff going on here in the 5th grade between recess and lunch. But right now in high school, you should not be saying 3 plus 1 equals 4 is difficult, and 3 minus 1 is 2, and that's difficult. Don't do that. People will think you're a lot less smart than you really are if you're tricking yourself into saying this is difficult. So, which one's smaller, 1 or a half? Yeah, half is smaller, 1's right there. Still need to do a check. Now, if you're not sure about common denominators and all that other stuff, here's what you can do. The check, if you haven't noticed, is your problem backwards. Right? So we went from 1, or from 4 over 4 to 1. That's a common denominator in reverse. Reducing 4 over 4 is finding a common denominator. So if I'm doing my check, I'd want to take 1, find a common denominator, which is 4 over 4. So if you're ever not sure how to do a check, look at the work that you did, and it'll be that work in reverse. Okay, we added 3/4 to both sides. We're just subtracting 3/4. 4 minus 3 equals 1. It's the same as it is above, it's just reverse. And that's really what a check is. You do the problem forward, just to make sure if you did it right, do the problem backward, it should work either way. So we have addition, subtraction, opposite, go back. Same thing here, if we're not sure how to do a check, but this is a fraction, we'll do 1/2 minus 1/4. Oh, common denominators, I don't know how to do that. Well, it's just doing this backwards. We went from 2/4 to 1/2, now we'll go from 1/2 to 2/4. Doing it in reverse. And again, 2 minus 1 is just 1. There's your check. a good motivation for showing all your work. If you show all your work, you just have to rewrite it backwards to do your check. You don't have to think about now how do I do the check, because I do everything right, but I'm not good at the check. If you show all the work, the check is the work backwards. And go from 1 to 4/4. Instead of adding 3/4 to both sides, you're subtracting 3/4 to both sides, ending up with 1/4. Working backwards. Right? And that'll get you what you need. So I'm going to have you do just a few of these for homework, and you can do a check and make sure everything's right. Anything you don't get right when you come in tomorrow, just try to put it ring, just get it out and say, I didn't get this, and you start working on it. So when you actually start going, everything's going to